Hello everyone, welcome back to Data Bracket. I'm sorry it's been a while. I am back with a new video. So in this demonstration we are going to perform some data engineering with DuckDb. So DuckDb is a new Python library that has come into light recently. I thought of testing it and honestly I'm impressed with the capabilities that it is offering. So DuckDb is completely built on C and it have wrapper functions and it have inbuilt capabilities to connect to Spark API and other databases. So this demonstration I'm going to showcase those capabilities. In this demonstration we are going to see how we can connect to Postgres SQL. So I have a Postgres SQL installed in my local. We are going to connect to this Postgres SQL using DuckDb and we are going to read some data. If the data is not available, we'll write some data into Postgres SQL. Yeah, let's do this. Instead of reading data from Postgres SQL, let's read a CSV file and we'll transform the CSV file using DuckDb's SQL capabilities. DuckDb offers SQL and Python both capabilities and it comes with many other libraries. So we are going to apply some transformations using SQL and then we will apply transformations using our favorite framework Pyspark. We are not going to install Pyspark locally and we are not going to set up any environment variables or configurations for Pyspark. DuckDb gives a very clean import for Pyspark. Through that, we are going to directly call Pyspark inbuilt functions and apply transformations with the speed of Pyspark. So after we perform transformation, let's write the data back into Postgres server. So this is going to be our use case and let's keep it simple and I'm going to perform 2 to 3 transformations after reading the data and write it back into Postgres. So let's get into action. Alright, here we are in our editor. So let's install DuckDb. I have already installed it, but you can install it just by calling the pip install. And this will install DuckDb, but for me it will complain that it is already installed. Oh, did I type duck? My bad. I'll put DuckDb and this will say it's already present, so I'm gonna skip this. So I have imported DuckDb and with that I'm going to import ConfigParser also. If you're following my videos lately, you know that I'll keep all my secrets in a secret file and I'll not expose my secrets in code. So I'm going to use ConfigParser to read my configurations and I'll pass those configurations to connect to Postgres as we go along. So that's one thing. So let's read our configurations from ConfigParser. So this is the secret file that I have. And in this secret I have 4 variables. One is username, database, password and port to connect to Postgres. So I'm just going to read this from ConfigParser. To read configurations from ConfigParser, we can assign it to a variable. And ConfigParser comes with the subclass which is ConfigParser. And once we instantiate this class, we can use this config variable and call the read method and pass the file where our configurations are saved. So my configurations are saved in DuckDb demo is the folder. Inside this I have secrets.ini is my secrets file. So this will read that file and I can assign the variables from the values that we get from the config parser. So I just have to do config the parent element which is Postgres and the child element which is user. This will give me my username. Same thing applies for password, port and database. So you can check out the documentation of ConfigParser if you're unsure what I'm doing, but it's simply how the structure in my secrets is like. I'll have a main parent. I can call it AWS and inside this I can have service 1 which is glue, service 2 which is RDS. So this configurations will be in that file. So once I read that file from the config.read using config variable, I can simply pass AWS as the parent element and service 1 because I want to get the value out of service 1. Service 1 will be the key. So what this will return us? This will return us value glue. So that is how ConfigParser work, but do check out the documentation if you're unsure what is happening here. And we need port and we need database. All right, so we have everything, all the variables we need. So we need to install Postgres. So this is very nice way to install extensions in DuckDb. These are called extensions. We can install database extensions for Postgres, and there are other extensions. You can check out the documentation. So all we need to do is we need to call duckdb.execute and simply call install Postgres. This will install the Postgres extension, and once the installation is done, we can call the same execute method and we can do load Postgres. This will load the Postgres extension and we can use this. So now we have our Postgres extension installed. Let's connect to the database and see how we can query the data. We can do again execute, and all we need to do is we can attach our extension. We can attach our configurations to a database. So what we need to do, we have to pass the db name equal to. So this is again already present in official documentation. I would recommend you to go and check it out. So I have it here. I'm going to simply paste it. So we are going to attach our database name, user, password and port. These are the variables that we are getting from our ConfigParser, and this will help us connect to the database. So we have these things. So to connect to, we have the connection to connect to Postgres now. So we can query the inbuilt tables like this. We can do duckdb.sql and we can call. So our database Postgres instance is referred to as database here. So we can do simply select all from db.pg tables. This is an inbuilt table inside the Postgres catalog. So let's assign this to a variable, and if I print this, we should see the data coming from pg tables. So let's run this python duckdb demo and duckdb.py. I haven't saved the file. Let me save and run again. So it says pg table does not exist. Why? It does exist. Let's see, calling it by pg catalog. Oh, my bad. We need to do execute instead of SQL because SQL will give us SQL capabilities. So let's run this one more time. Table with pg table does not exist. Tables it is. Why am I doing so many typos? Okay, I think it's already connected to database, so we don't need to specify the db. It clearly shows us here db is what we are passing, and it is passing the pg catalog.pg tables. Let's simply call pg tables without passing anything. It should connect to the default database, and it have returned us the value. Instead of execute, if we do SQL, then this should give us the output, right? So execute was executing and giving us back the object, but SQL is giving us the SQL response, which is nothing but a data frame. Again, this is not a data frame. If we try to print the type, it is some Py inbuilt class specific to DuckDB. We can see that it is a class of DuckDB Py relation. We are going to see how we can convert this into a data frame and how we can convert it to Spark data frame specifically to perform Spark transformations. So we are successfully connected to Postgres now. So in order to write some data into Postgres, right, I have a data file which is nothing but fake currency data which I downloaded from Kaggle. So we can read this CSV file from DuckDB easily by simply calling from CSV, read CSV. So all the methods on this DuckDB class is similar to Pandas. So we can simply pass, this is in our data folder and my file name is fake currency data.csv. So if I assign this to a variable, fake currency, and if I print fake currency, then we should see the data coming in from that CSV file. So you can see how fast this is running, right? So it is we have so many rows in that, but it is running very fast compared to Pandas. It is connecting to Postgres and it is reading the CSV file within millisecond latency. So we have read our CSV file now, and let's perform some transformations. So we can perform directly transformations using SQL. So this fake currency variable, we can use it inside a SQL query. Like, let me show how. So I'll assign this to a temp variable, and if I do DuckDb.sql, and if I run select all from fake currency where, okay, let's see what columns we have before we apply some filter. If I print temp var, we should get the same variable that we got when we read it as read CSV, right? We will get the same output. There is no difference. The best part is here we can use this variable as an view inside the SQL. That's a great thing, right? We don't need to convert it into a temporary data frame or temporary view in order to use it from SQL. Any variable that we read from DuckDb, we can use it directly inside a SQL statement. So let's filter country. Let's filter where country is UK. Let's see if this works. This should give us all the rows which have only UK as country. So yeah, that is working perfectly fine, and you can see the speed again. It is taking millisecond time to run and return outputs. So this is the best part, and as we can see, we can run SQL statements. Now we have this variable. So let's see how we can convert this variable into Spark data frame and apply some Spark transformation. So generally when we want to use Spark, right, we will install Spark separately. We need to install Java, we need to install many other things. But with DuckDb, the good part is it have an experimental feature. Experimental feature where we can directly import all the Spark functions just like how we do it in Spark. Spark.sql is how we use it in Spark also. Import Spark session. So this is how we import, right, Spark session in Spark, and we can name it here only as session, and we'll install some other Pyspark inbuilt functions in order to perform some transformations. DuckDb.experimental.spark.sql.functions import. Let's import call. We'll apply some transformations on columns, and import when. We'll do some conditional when and otherwise. And let's import let in order to cast, or in order to insert some values into the columns. So we have our temporary variable. So as we can see, right, if we print type of temp var, they should say class, right? So it is a class. Now if we simply do .df, this will get converted into a data frame. See, we can see it as a data frame. It got converted into Pandas data frame, but it is a data frame, right? We can use this data frame and create it into a Spark data frame. So all we need to do now is create a Spark session and create a data frame out of this. So let's say this as temp df. This is our data frame. So let's create our Spark session dot builder dot getter. There is absolutely no difference from Spark and DuckDb. We are using all the functions that we have in Spark in the DuckDb. The only thing is this is experimental. It's not full-fledged production ready yet. So we can simply do, this is our UK data, right? Let's call it UKDF equal to Spark dot create data frame using temp df. So this is our Spark data frame. Very simple, right? Now if you want to perform some Spark transformation, I can simply do ukdf equal to ukdf dot select. This is again Spark syntax, right? Select country. If I do print ukdf, this should only return me the country column from the data frame, and that is what it is doing. And if we do ukdf dot columns, which is again a function for Pyspark, it should only print us the column names from that, right? See, if we comment this, it should return all the column names, just like how Spark would do. Absolutely beautiful. So we have our Pyspark functionality enabled now. Let's apply simple transformations, right? So let's apply ukdf dot show. We can call show function also, which is part of Pyspark. So this will show the data frame to us. So what we are going to do, let's filter values from this column where the values are greater than 0.5, right? Let's do that first. ukdf dot, let's call it as a new, let's create a new column. We can use when otherwise. So let's call it high thickness for the lack of better name. And in this column we are going to apply some transformations here. So let's say when our column thickness is greater than 0.05, let's wrap this inside one more parenthesis just to make sure that this is considered as 1. Then we'll just keep column thickness, whichever is greater than 0.5, we'll keep that in our data frame. And again let's okay, let's keep this for now, and let's see if we get the output correctly. Let me run this now. Missing one. Oh my bad, this parenthesis is front and back. So if I run this, this gives us all the values with the column high thickness which are more than 0.05. This is again working just like Pyspark. This is Pyspark, but we are using it through DuckDb. So let's apply one more transformation. Let's say we want the ukdf to have only rows where the security features are watermark, right? In Spark we'll simply do where or filter where our column security features is equal to watermark. This will give all the rows which have only watermark and the thickness is greater than 0.05, right? So we can see all the values are watermarks and all the values are above 0.05. No values are below 0.05. This is pure magic. Yeah, this is why I like the library so much, and it's happening real quick, right? We as data engineers are all about speed. So this is giving very much low latency results and is working flawlessly. So now to write the data back to Postgres, all we need to do is DuckDb dot execute, and all we need to do is create table. If not exist, this is again plain Python or plain SQL. We have DB element. Now the DB element comes into picture because we are running the execute function. So if I just do DB dot and let's call this UK watermark. Yeah, let's call it as UK watermark, and it's as from. Again, the magic of DuckDb is we can use that ukdf variable data frame as view here. So what this does, it will create a table using this ukdf. We don't have to specify column, we don't have to specify any schema. So if we go to pgadmin, if I try to run this, I will not see any data because this does not exist yet. So if I run the Python file, what does it say? It's either a Pandas Dataframe. Okay, it should be Pandas Dataframe. We are using Spark Dataframe. Let's simply call this .df. I think they should convert it into Pandas Dataframe. Let's try running it again. The Dataframe has no object df. I guess we can do this. I think we can call to pandas on this, and is that the one? I'm not sure the function, I need to check, but let's run this and see. They should convert it into Pandas Dataframe, and yes, it did convert it into Pandas Dataframe. Let's go to our pg admin and let's run this now. pg catalog dot still says it doesn't exist. What did we call it? OK watermark. Okay, I did some debugging. I'm 100% not sure why that failed, but if I'm giving some other names, UK, I think it will not support underscores, or it will. UK watermark sample. If I run this DuckDb.py, this has run. If I run DuckDb.sample, because when I just gave it as UK it worked, this should also work. Yeah, see, it created a table in Postgres and we should see the transform data. These are all above 0.5 and only have watermark data. I'm unsure why that failed in the why we are not able to see the data in Postgres. It ran successfully, but my Postgres refresh didn't work, or I don't know. But I have not done anything behind the scenes. It's just the same function. We converted it into pandas and we wrote that UK df into Postgres and just named it as different name. Alright guys, I think that's all for this demonstration. This might be useful for you people in your daily work, and please to leave a comment if you liked the video and if you want to see more on new tools. I'm going to explore other tools and I'll make sure to post content regularly so that everyone can benefit and everyone can learn data engineering and machine learning operations. I'm also trying to curate courses or videos on MLOps and DevOps, so please to stay tuned for those as well. Thanks for sticking till the end. Bye.